Okay, as a final note for this lecture, I wanted to provide a reminder and emphasis on the point that we've been looking at regular expressions which provide tremendous power. They do have the potential, particularly in the Unix context, for being quite confusing, because the wildcard expressions, the file name patterns we see in the shell, make use of a common set of characters with them. Characters that we'll use commonly in the shell include star and begin bracket and dot, as well as other words. And it's very important to keep these distinct in one's mind, and secondly, to undertake prophylactic measures that will prevent something that you mean, for example, to be interpreted by grep from being interpreted instead by the shell, which is the primary risk. I want to distinguish conceptually between these two types of things. So file name patterns, you'll recall from previous discussions, are interpreted by the shell prior to the command, the process associated with command, in this case a tool like grep or egrep or fgrep, from being invoked. Okay, so that work of unpacking file name patterns, of unpacking these wildcards on the file name, on the command line, things like ls star.txt or what have you. These things are interpreted by the shell prior to the command, prior to grep wake sort of being, coming to existence as a process, having a process created. And so when it's given its command line arguments, it's told, the things that are results of that file name expansion. So if we have grep file1 star.txt, by the time the grep process comes around, it's given file1 as an argument, as well as anything that matches the star.txt. Okay, and by contrast, a regular expression is typically an argument to the command being executed. It's the thing we want to give to grep. And a really good practice, a key practice here, is to put that in single quotes. Why single quotes? We discussed it earlier. Single quotes are your insurance that the things inside the single quotes won't be interpreted by the shell. So the shell won't muck with this. It won't mess with it. It won't frob it. It will leave it be. Okay, and that's typically what we want. If we want to get some sense of this, we can use the echo command. Okay, and it bears noting that grep does have a requirement here for for this syntax, that there's a pattern specified. No actually requirement explicitly here. You have to specify either this or this. So let's go. We could use the echo command, for example. So if we were to say echo rather than grep, something like star.txt, what are we going to see? It's actually going to echo what it gets. By the time echo comes into being, again, the shell has already matched the 6. And similarly, it's going to be the same case with grep. Similarly, if we had something like foo star, this is what echo sees. This is what's given to it. It's as if we type these in. It's as if we type foo dot txt here. Oops. Foo bar and foo baz. Okay, so that's all done prior to when echo gets in, prior to when grep gets it. These file name expansions. So you have to keep this distinction state, and I'll sort of let you puzzle over this. So what are the semantics associated with these two things? So if we have grep star.txt file1, what's going to happen there? Well, it's quite interesting. If there is a file star.txt, if there's something for it to have, if we say grep that, well, it'll be similar to we saying echo star.txt file 1, okay? This is what echo gets, this is what grep will get. It will actually get this, okay? Now, here it's actually expanded this this thing. So it's expanded this out and turned it into a file, and grep isn't going to see it as a it's going to see this as its first argument, as its pattern, okay? It's not going to see what we gave it, this star dot, which is good because it doesn't really make sense. Okay, so if we had put that in single quotes, something like this, it would have, well, okay, yeah, it's saying there's no file 1, so I'll do it here. In this case, it's trying to look for that pattern, but because we didn't put it in single quotes, you know, so if we did echo this foobar, it will echo that thing exactly. If by contrast we say echo just with this, it's actually going to expand it. Okay. Now how about the second one? Grep dot star txt file 1. Well, we could do the same thing here with echo. So we could do dot star txt, for example, and it's actually found a file called .txt. So that will get expanded, that will get passed to grep, and it will be looking for something called .txt, okay? Now that may not be exactly what we meant, because here we wanted a star, and instead it's putting a .txt. Now, the contents of foobar are not particularly privileged, as I think you folks realize, so I'll take the liberty of overwriting this. Okay, and how do I, so it's saying I can't overwrite it because I've got no clobber set, so how do I change that? Well, remember, one way to do it is through this. Okay, I'm in bash, so I can do this. So let's do a little text test here. Let's have something called a txt in it, right? We'll have something that just has the word txt in the next line, and we'll have something that, although those two actually should be sufficient. So if it's getting this, it should match how many single characters before txt? If it's getting, in other words, this guy here, if grep actually sees that, how many characters? Single characters need to precede txt, 0 or more. So it should actually match this txt line. By contrast, if what it's getting is this .txt, it needs at least one character before it will only match this line and not that one. So let's give grep a try with that. So let's have it do grep for this. It only matches that line. Why does it only match that line? Well, the echo, trying it with echo, told us. Because this is actually what's given to grep, this .txt.foobar. And this .txt doesn't have that star in it. So it's saying match, you know, only a line where there's a single character before txt, and there's only one such line, namely this one here. That was the one printed. Ladies and gentlemen, by contrast, the only reason that happened is because there was, in fact, a file called .txt. And to be honest, I engineered it as such. If we remove that file, we remove .txt. Now what's going to happen? Well, we could see by doing an echo, we could say, okay, what's going to happen now? It can't find such a file, so it's giving this as the first argument. So what do you think grep is going to give as a result? It's going to match both lines, because now finally it's getting what we want it to get. Why did it actually see the full thing now? Why did it see that? It's because it couldn't match a file name with it, so it just passed it on. Where it could match a file name before, it did so, and it passed on the name of the file, which caused a very different interpretation. So ladies and gentlemen, Here we have a situation where the vagaries of what files happen to exist can change the semantics of what this means. Can change the semantics of this command. Just because you have a .txt file around but someone else doesn't, you're going to have different operations of this. That is not something you want. So ladies and gentlemen, as a general rule, if you want to give something to grep very clearly, you can do so by putting it in single characters and be guaranteed of a correct, that it will pass it on to grep in that sort of way. If that's helpful.